You're not going to believe this. This is the most simplest thing in the world, and nobody's thought of it. But here you go. A guy whose name I do not recall, he runs the site Ritali.com. I'll spell that for you. R as in Robert, I as in independent, T as in Thomas, A as in apple, L as in lampshade, I as in independent, E as in Edward.com. Ritali, however you want to pronounce it, Ritali.com. Now, he's got a charging methodology that uses voltage to charge the battery, the lead-acid battery, rather than current. Yet when it discharges, it still discharges current. The beauty of the system is that, first let's analyze a normal full cycle of a lead-acid battery under normal conventional standards of charge and discharge. No, forget the discharge, because that's always the same. It's the charging that's different, and it changes the chemistry of the battery. The structure of the battery is different. If you use voltage to charge the battery versus current, and I mean strictly voltage, with current there only as a token gesture to support Ohm's law. No more current than what's necessary. So you jam 400 volts into that 12-volt battery, and you use just enough current to barely give that voltage existence. Otherwise, you don't need the current. But you do need it because you got to follow Ohm's law, okay? But when you discharge it, everything is the same. Now, the difference, though, the consequence is when a battery is discharged, hydrogen ends up above the electrolyte. It accumulates. So we have a dangerous condition because hydrogen is explosive and it's free. It's just sitting there in this air gap between the electrolyte, the surface of the electrolyte, and the top of the battery where it was sealed. Okay, the openings were sealed. So now during the discharge, there's a congregation, an accumulation of hydrogen gas. Okay, that's when you charge the battery with current. And the voltage is quite low. Standard is 13 to 14 volts. That's pretty low comparison to 400 volts, okay? But if you use this other method of using high voltage, a different thing happens. Instead of hydrogen building up during the discharge cycle, oxygen builds up on one of the plates, the plate that is coated with lead dioxide. It ends up migrating. It pushes it's already coated with lead dioxide. The lead plate is coated with lead dioxide. It pushes that oxygen in. It migrates to accommodate the extra oxygen that's being forced onto that coating of lead oxide. So you get a thicker coating of lead oxide. And those plates store more oxygen, and they store it during the charging cycle. Whereas in the conventional manner, hydrogen accumulates during the discharge cycle. Instead, this high voltage charging technique stores oxygen during the charging cycle, and that's flammable too. But it's bound to the lead as lead dioxide, so now it's safe. So it's actually a safer battery. And the wattage, according to the guy who runs the Ritali site, I haven't done this, I'm just trying to analyze the process in my head, what must be going on. And so it's this purely speculation on my part. Tell me if I'm wrong. But he's claiming that the wattage needed to charge the battery under these conditions of 400 volts is less than the wattage that the battery discharges during its discharge cycle. So you end up with an over-unity device using this methodology. But it's a two-part process. You still got to charge the battery, and you still got to discharge it. But the end result is over-unity because you get more out of the battery than what you put into it in terms of watts. Now, people will claim, oh, it's energy from the vacuum, it's from the ether. Bullshit. It's simply a question of how much wattage does it take. I'm sorry, that hurt to say that, but I got to say it. You got to ask yourself the question, how many watts does it take to split the lead sulfite and send the lead back to the spongy lead plate? Because I'm guessing that's where the lead came from to form lead sulfate in the electrolyte. And that drives what that spongy material is being discharged, and that drives hydrogen off of the hydrosulfuric acid, or out of the solution of the hydrosulfuric acid and into the gaseous or the airspace above the electrolyte. How much energy, how much watts, how much power is released when that hydrogen gets released out of the liquid, versus how many watts does it take to force migrate oxygen into the other plate that's coated with lead dioxide? How many watts does it take? Because the end result is the same. You get an imbalance of the water molecule, but it's opposite. And it's opposite in terms of which half of the charge-discharge cycle is this imbalance of the water molecule occurring. But ultimately, you have to ask yourself the question, how many watts does it take with one system versus the other system? The conventional system versus the system used by the fellow who runs the Ritalai.com website. Because ultimately, that's what it comes down to. Now, I did a thorough analysis of the Stanley Meyer method of running water and air to run his engine. And of course, he always misrepresented it because he didn't want to give away any secrets. But I did an electronegativity analysis, and it came out over unity. I could see it chemically that it was over unity, because he's not running his dune buggy off of water alone. That was just a lie, a misrepresentation. He was running it off of nitrogen in the air by using high voltage. 70,000 volts is what Herman Anderson used, so I'm speculating that's in the ballpark realm of what Stanley Meyer must have been using, because Herman Anderson did the same methodology. He just didn't advertise. He was not an evangelist trying to make a lot of money. He just did it for his own amusement. And then when he approached death, he gave away his secret to some college professor and a few of his college students, and they taped, and you could barely hear what the guy was saying, but you get the gist of it, that it's pretty much the same as Stanley Meyer. So he used 70,000 volts positive ionization to split the dinitrogen molecule from the air, and then he used the same voltage to ionize after the water has been split into hydrogen and oxygen gas. It's ionized with the same voltage, 70,000 volts positive ionization, and then the two mixtures of gases are blended, and then the voltage is dropped back down to normal. Now, if you dropped it back to normal without mixing the two, the nitrogen would go back to being dinitrogen, and the HHO would go back to being water. But when they're mixed, and I suspect in order to do this, it isn't dropped down to normal. Actually, he has to reverse polarize it, because you got to send that 70 volts negative somewhere, right? So you send it back to the reforming chamber. So when it goes negative 70,000 volts, now the nitrogen bonds to the hydrogen in such a way as to form ammonia and hydrazine and a few other chemicals. But now you've got something you can burn with. But Stanley Meyer would always have a little hydrogen left over. He would always blend it so that there would be a little left over, because you got to use the hydrogen to ignite the ammonia, because ammonia does not want to ignite very readily, but hydrogen ignites very readily, but it doesn't give you any energy. It implodes. So you got to have the ammonia for the energy, but you got to have the hydrogen to ignite it. And we already know about the guy, or maybe you should know, I should remind you of the guy in Florida who went around and collected this spongy, moist mass of orange juice pulp left over after the oranges are squeezed to make orange juice, he would collect it, and he would use an energy-efficient method to split the water molecule to form HHO, and then he would use the hydrogen of that HHO, or else he would divide it into hydrogen and oxygen. I can't remember which, but he would use the H to ignite the wet orange pulp, and he was burning the orange pulp even though it was wet, and it was free. The orange juice presser said, "Here, it's free for the taking." And all he had to do was use a little energy to split the water molecule to ignite the wet orange mash. And he had a very small, lightweight car, and he was running his car for practically nothing. The cost of gathering water, basically, and the cost of driving to pick up the orange mush is for free, because he's using the orange mush to get there, to burn to get there. So he was doing something similar, because the orange mash needed a very highly flammable or a highly ignitable gas to ignite, or in this case a gas, to ignite that orange wet mash in order to burn it. And he was doing fine, running his car on orange mush. Well, Stanley Meyer decided not to use that, but to use the nitrogen of the air. But you got to get it somehow, and so anyway. So I did an electronegativity analysis of the process of Stanley Meyer, and I came to the conclusion you get more energy out than in, because that's the way the analysis works. When you look at the chart of electronegativity of ammonia and hydrogen and all the different elements and compounds that you're dealing with, and you work it all out, the equation, and the math comes out to be over unity. So I have to imagine, I haven't done this electronegativity analysis, but I'll have to now that I'm saying this. I'll have to see if the math works out. But my guess estimate is that it takes less wattage to run a lead-acid battery in the Ricci method than it does in the conventional method. In other words, yada, yada. I already said it, so I'm not going to repeat myself. And that's really what it comes down to, is you do the cost analysis in terms of electronegativity of the elements and the compounds involved to figure out if it really is over unity in the chemical method, and instead of taking somebody's word for it. But this is what I suspect is taking place. And for somebody to say that perpetual motion does not exist is a bunch of hooey, because technology makes it possible if you do the analysis of somebody else's success story, so that you understand why it's a success story instead of taking somebody's word for it, or do the opposite and naysayer. You just say, "Oh, it's a bunch of BS." Did you do the work? Did you invent it? Did you do the work, or did you do the analysis? No. You just say it's BS because you just want to say that because it's the religion, Everybody's doing it. That's appeal to emotion, appeal to common sense, and appeal to authority, because all three are taking place, and all three are fallacies of logic. Yet everybody does the same mistakes. The threesome, the big three mistakes in Western culture. Bad method without doing any of the homework. So now that I've worked out my speculation as to how the chemistry must be occurring, all I have to do now is do the electronegativity analysis to see if it pans out. Because I already did it with Stanley Meyer, and I posted it on my website, stanleymeyer.info. So I already did the work to verify what Aaron Murakami was saying in his waterfuel.com, I think it's website presentation. It costs just a few bucks. But who did the analysis chemically to figure out why, to verify why it's over unity, the Stanley Meyer method. So now all I have to do is figure out if the Ricci method is also over unity, chemically speaking. Mathematically, work out the math. It's just simple math, It's not trigonometry or calculus or anything. I had algebra in high school, so I know how to do algebra. It's not hard. You just do the work. So there you go. So even before I do the work, that's the answer to your protestation. I forgot your name. Sorry. I think it's Gutierrez. perpetual motion machines do not exist? That's because the inventors have either been sidelined in a gentle manner by us ignoring them, or in a very violent manner in Stanley Meyer's case. He died suddenly. And we don't have to get into why. He just died suddenly. Let's leave it at that. We don't have to argue on sidebars issues as to how did he die. Who cares? He just died suddenly, and that was the end of his story. But if you do the analysis, it's not the end, because it is over unity. The math works out. So there you go. Perpetual motion does exist. But don't think of it as a machine. Think of it as an algorithm. You know, when you do an algorithm, you have to do multiple steps. And the steps sometimes are in subdivided boxes. So you don't do all the steps in one string. Then you have to move over to another box to do a different string of processes. So the processes are separated from each other, but they're grouped in sets. And that's why I say an algorithm, because a machine per se can also be made up of steps in which a certain portion of the machine is running, and then you switch off that portion, and now you have to run another portion. And that's the way I've designed my over unity circuit simulations in terms of cycles, in which you run one portion of the circuit or the whole portion in one cycle, and then you flip it into another cycle in which this circuit runs in a different mode because a switching occurred, let's say, to switch different elements in and out. So actually you're switching in one section of the circuit and you're switching out another. So it's the same thing with any kind of protocol. We go to sleep and we wake up and we go to work. We go to sleep, we go into bed, right? We sleep in bed, but we go to wherever we work to work. And we don't do this, we don't mix it up. We don't work in bed, well, some people do, and we don't sleep at work. Well, some people do. But in normal life, you do each in their own respective places. Each has their own respective activity or endeavor. Whether it's activity or non-activity, each place has its own endeavor appropriate for that place. And it's no different in any other situation. So if the oxygen migrates into the lead dioxide plate as opposed to hydrogen being released above the electrolyte, those are different things moving into different areas during different cycles, providing a whole different unique setup. So this will be interesting to see if the math works out. But in Stanley Meyer, I already did the work. So perpetual motion does exist. But with anything, wear and tear, takes its toll. According to Ritolai, the battery lives longer and you can revive a battery that's lost the capacity to store a charge. So that means, and then he said you have to always charge it this way. You can't flip back and forth, use conventional methods versus the Ritolai method. You can't. You have to use the Ritolai method, and as you keep charging with that method, the battery's life is longer, so it's like it takes better care of the battery. And we all know that when you supercharge using a Tesla supercharger or turbocharger, it's high current, it's massive current, and you end up reducing the lifespan of your battery. So we already know that current damages the lifespan of the battery. So simple logic, you would think, yeah, the less current you use and the more voltage you use to recharge a battery, it should improve the lifespan of the battery. And that's a good thing, because eventually you're going to have to replace the batteries anyway. They're not going to live forever. But the question is, how long can you make them live for? If you can make them live longer, that saves you money. So it's not only over unity, but it saves your wallet, because you don't have to replace the batteries as often. So, you just think these things through. So perpetual motion, yes and no. You still got to replace batteries. But the cost effectiveness, that's what matters. And if you do get more energy out than in per whole cycle of charge and discharge, considered as half cycles, then, because that is an AC cycle. You understand that, right? The DC energy coming from a battery is an AC system. We just don't think of it that way because it's not 60 cycles per second. Instead, it's however long it takes to discharge a battery versus charging it, and then you add that up, and that's one cycle. So the cycle time is longer, but it's still an AC cycle because the current reverses, right? Something reverses. the voltage, the voltage. The voltage reverses regardless of anything else. So we still do AC, we just don't call it that. But it is. This is very important when you analyze things. When you analyze something new, you have to go back and analyze something old and rethink it now using the new terms to rethink how you analyze the things, the conventional things, a new way, so that you can see, oh, we've been misdiagnosing this stuff all along. It's no wonder we don't understand over unity, because we only analyze it one way and one way only, as if it's dirty business to be anything other than Catholic, you know. Come on. The Protestants protested Catholicism, you know. So there are other ways of looking at things which engender other protocols of endeavor. How to treat a battery during the whole cycle of each half discharge and half charge cycle, or recharge, half discharge and half recharge cycle. That whole cycle is done a little differently, a different religion. We do things differently as Protestants. We're not Catholics. It's the same battery, we just deal with it differently. Okay, enough said.